Alright, so we're ready for problem F on section 4.7. Here we go. We're going to find the angle whose tangent is -1. Now, I told you that if this was a negative number, I would tell you which quadrant it's in. So this one is going to be in quadrant 4. And I'm not making that up. Again, there are rules for that. I'm just not requiring you to know those rules. All right, so I'm going to draw a picture in quadrant 4. And the tangent must look like that. Opposite over adjacent. Can you tell how big this angle is? 45. But 45 is not the answer. Don't put 45 down as the answer. The answer is the up and around. So that would be 315 degrees. And how did we get that? How did we get 315? 360 minus 45. Very good. Very good. Okay, a couple more. This one, where are you going to draw this one? Where's that going to be drawn? 1. Yeah. If it's positive, it's going to be drawn in quadrant 1. Where did the root 3 and the 2 go? Opposite is root 3. Hypotenuse is 2. That's going to make that a 1. How big is that angle? 60. So the answer is 60. If you're in quadrant 1, your angle is the answer. It's only if you're in another quadrant that you have to mess with it. Okay, here we go. This is in quadrant 2. So I got a triangle in quadrant 2. Where's the root 3 go? On the bottom. How big's the angle? 30. But the answer isn't 30. What's the answer? 150? How did we get 150? 180 minus 30? 180 minus 30? Oh no. Oh no. Think about all the work that we've done. When do we get zeros? We never get zeros when we're drawing triangles like this. There's no zeros on any of those. When do we get zeros? When it's on an axis. So we get zeros when we look at our circle. That's the only way to get zeros, is to be on an axis somewhere. So this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now I'm going to let you catch your breath. How did I get those points? No idea.
Did you just know it?
No. I mean, I do, but there's a reason for it. I made up the radius, and what did we say we were going to let our radius be? 1. So if the radius is 1, here's the origin. If I come out here, isn't that the point 1, 0? And this would be 0, 1, and negative 1, 0, and 0, negative 1. And every time we have to draw a circle for a problem, we use a radius of 1, just to keep it consistent and easy. It's called the unit circle. Now, what is tangent on the circle? What's the circular definition? Please don't say opposite, or yeah, opposite over adjacent. What is it on the unit circle? Y over X. So I want you to start right here. We start here because this is 0 degrees. If you put Y over X, remember this is a point. If you put Y over X, do you get 0?
Yes. Yep.
Oh, then that's the answer, 0 degrees. Now, if you hadn't gotten 0, then we would continue up to here and see if that worked. And we just make our way around until we find one that works. This one happened to work right off the bat, so that's the answer, and we're done. I think there's one more. Sine 0. I'm going to go ahead and, I know it's not on your sheet, but I'm going to do cosine 2. Now, when you see that 0, gang, you are using your unit circle. Whenever you see a 0 here, you know you're on an axis. So you know you're one of these quadrantal angles. So, I need the sine to be 0. What's my circular definition for sine? Y over R. Okay, R is 1. So right here, Y over R, would that be 0? Y over R? It would be, wouldn't it? So the answer to this one is also 0 degrees. Because right here, that worked. Y over R gives me 0. I don't want to add this one in because both of those came out to be 0, and I don't want you to think it's always 0.
Alright.
So here we go. What's the definition? This is X over R. Good. So if I put R is 1. If I put X over R, does that give me 0? No. Let's try up here. If I put X over R, does that give me 0? Yes. So the answer to this one is this angle, which is 90. You just keep trying the points until one of them works. Gives you this number right here. Okay? All right, one more part in this section, and then we'll do some review before we do the word problems. We have to find the exact value, and these problems look terrifying.
Oh my.
I know, look at this.
Crazy.
Crazy is right. Now, I'm going to cover this up for a minute. That looks exactly like the problems we've been working on, right? So I'm going to draw this in quadrant 1. Why am I drawing it in quadrant 1? It's a positive number. So I have an angle, and I know the tangent, the tangent is 3/4. Uh-oh. That's not a 45 or a 30 or a 60. So let's do the Pythagorean theorem and see what that other side is. Did you get 5? We have no idea what that angle is. It's not special. But here's the good news. We don't care. Because what we want to know about it is its sine. So can you look at that picture and tell me the sign? What's the sign? 3 over 5. So the answer to the problem is 3 over 5. It's not a special triangle, but we don't need to know the angle. All we need to know is that opposite over hypotenuse is 3/5. So not nearly as scary as you thought. All right, here we go. Here's another one. Who can tell me how to start? What is the first thing I want to do? Draw a triangle, because I'm not looking at this right now. I'm going to draw a triangle. And I'm going to label a couple of the sides, right? It's a sine, 5/13. So 5/13. Does that make sense? And then I need this one, right? And how will I find that? X squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169.
Yes.
X squared equals 144, so x is 12.
Okay.
So I've drawn this picture. Now what do I want to know? This is what I want to know. I want to know cosine, so the answer is x over r, or adjacent over hypotenuse. So that will be 13. Hang on, just a few more, and then we'll do some exciting review.
I like triangle.
Yes, it's exciting. Now, this one has a negative in it. So I need to tell you which quadrant. You're going to draw this in quadrant 4. Alright, so here's my triangle in quadrant 4. And I'm ignoring this. This, I don't need this yet. I need my sine, I'm in quadrant 4. I need my sine to be negative 4/5. Now what do I do? Some of you are frantically writing. What are you doing? You're figuring out the other side?
Yeah.
Did you get 3?
Of course.
All good. What do I want to know? I want to know the tangent. What's the tangent of that picture? Negative 4/3. This parentheses part of the problem here, that's your picture. This is what you want to know about the picture. So first you got to draw this picture. Then you're going to find the tangent. Now we've been really lucky so far. We haven't had any radicals. This one's going to have a radical in it, which isn't the end of the world. We're used to it. Alrighty, first. Draw my triangle, and since it's a positive number, it'll be in quadrant 1. Now what am I going to label? Jacob, you awake, sweet pea? Try real hard. What's tangent? Opposite over adjacent. So can you see a radical coming in? What's it going to be for that hypotenuse? Root 13. How did we get root 13? 9 plus 4. So here's my picture. This right here is right there. Now I want the cosine.
Yes.
So what's the cosine of that picture?
3
3 over root 13, or 3 root 13 over 13? Now don't panic when you see this next one. It's positive, so I'm going to draw it in quadrant 1. Ignoring this, don't let that confuse you. Where do I put the root 7 and where do I put the 4? Root 7 is adjacent. Hypotenuse is 4. So here we go, Pythagorean theorem. We have root 7 squared plus x squared equals 4 squared. What's root 7 squared? 7. So I got 3. Did I do that too fast? Did you get 3? Well, there's my picture. What do I want to know? Sine? What's the sign? 3/4. Perfect. One more. Will you try this one on your own? Do it in your notes and see how far you can get. See if you can draw your picture and find the tangent. Please draw your picture in quadrant 1. Anybody else get root 7 over 3? Anybody have a question about that? Anybody not get root 7 over 3 and want to know why?
I don't know how you got root 7.
With the Pythagorean theorem, we knew, so 3 squared plus x squared equals 4 squared. So that's 9 plus x squared equals 16, so x squared has to be 7. 16 minus 9 is 7. Okay? Alright, well let's put those notes away. That's enough cramming in your poor little head for one day. And let's look at our practice quiz. This is a little bit bigger quiz. It's got shots on the front and the back. Alright, so now we're kind of switching gears a little bit. This doesn't have anything, I mean, it's not what we were just doing. This is something that we did before.
Each one of these is worth 5.
Pardon me?
He said it'd be worth 20. So
It's got a backside too.
yeah.
Alright, so here we go. The first one is sine 3 pi over 2. This is a no calculator quiz. This is no calculator. So you're going to do this whole thing without a calculator, but you can do it. What do you think might be a good way to start this? We have to find the sine of 3 pi over 2. Yes, Gavin?
Put 180 in.
Yep, exactly. So pi is 180. Divided by 2 is 90. Times 3 is 270. So we're finding the sine of 270. Wait a minute. Where's 270?
It's on the,
It's right here, right?
on the board.
So when the point you plot, or the angle you find, when the angle is on an axis, we do not draw a triangle, we draw a circle. We only have to do that if we're on an axis. If we were out here somewhere, we'd make a triangle. But when we're on the axis, we have to use the circle. So what point is that? 0, -1. So my x is 0, my y is -1, that's straight from the point, and my radius is always 1. Sine. What's sine? Well, opposite over hypotenuse, but that doesn't work if I don't have a triangle, so I gotta do y over r. So y over r would be -1 over 1, which is -1. For all these problems, you're going to draw your angle. If you're that's the first thing you're going to do is draw your angle. If your angle happens to be on an axis, then you're going to use the circle. Tangent, -210. First thing you're going to do is draw your angle. -210. Negative. What do I do with negatives? I go this way, right? So -210 would be right here. Now before we go any further, let's make sure everybody's clear on that. This negative means I go down. This is 90. This is 180. 210 has to go past 180. Butterfly bow tie triangle. What is the measure of this angle right here? 210 minus 180. We always use 180 or 360.
30.
So this is going to be a 30-degree angle. 210 is 30 degrees past 180. What's this side? 1, √3, 2. Any negatives? Make sure you catch yourself. Any negatives in that picture? This is. How do I know that? This is on the left. Exactly. So with the tangent, what's the tangent? This time I can do opposite over adjacent because I have a triangle. So it would be 1 over -√3 or -√3 over 3. What are you doing?
Sorry, I'm spacing out. Tired. Last night.
Emmett?
Yeah.
Give it to me. Alright, so that's my answer to that one. Okay, so now we have the next one, alright? Let's see. Cosecant, pi over 6. Pi over 6. 180 divided by 6, that'd be 30. So cosecant 30. I'm just going to draw my 30-degree angle. That one's easy. It's right here in quadrant 1. 1√3, 2. Do I have to worry about negatives? Not in quadrant 1. I want the cosecant. Cosecant would be hypotenuse over opposite. So 2 over 1 or 2. cosine 225. Where is 225? Quadrant 3. Start here. Go up and around. Here's 180. You gotta go past 180, right? So this angle is 225. That's going to be a 45 because 225 minus 180.
Yeah.
We went 45 degrees past 180. So 1 root 2.
Is that a negative one?
They're both negative ones. Right? Because we are left and down. I need cosine.
Adjacent.
Negative 1 over root 2 or negative root 2 over 2. Does anybody have a question about those 4 problems?
No.
Why did I draw a circle with the first one? Because when I got my angle, it actually was on an axis, right? So when that happens, you draw your circle. Otherwise, you just draw your triangles.
About the third one, how do you know it's in quadrant 1?
Because 30 degrees is between 0 and 90.
Oh, okay. Never mind.
Right? Remember, this is 0 and that's 90. All right,
Yeah, 30.
on the back, you've got some sketches.
Never mind.
So not only are you going to have to sketch, but you're going to have to list the amplitude and the period. This should not be a challenge for you. You get half credit for the sketch if you just draw the shape right. This is a sign. It's going to be a hill and a valley. That's it. So that's half credit for the picture. Now to get the rest of the credit, you got to come up with these labels. So we remember what the labels are supposed to be. This is supposed to be a 1. But what happened? It's going to be a 2 because it got times by 2, which means my amplitude is 2. These are supposed to be 90, 180, 270, and 360, and please write them down below. Your answer goes up here. This is my work down here. This is what they're supposed to be. But what happened? I'm going to divide by 3. Which means the real labels are 30, 60, 90, 120.
Yeah.
Which means my period is 120. Anyone have a question about that?
No.
Now I have a cosine. Now normally cosines start up here and end up here like that. That's what a normal cosine does. But what happens to this one? It's negative. So instead of starting up like that, it's going to start down like that. Make sure when you draw your cosines that they are ending where they started, okay? Make sure they are ending where they started. So if it starts up, it ends up. If it starts down, it ends down. So your hash mark is the down point there, the end. All right. Amplitude is supposed to be 1, but I put a 1/2 out there. So are you okay with those labels? And the amplitude is a 1/2. Please don't put negative a 1/2, it's a 1/2. These labels are supposed to be 90, 180, 270, 360. But what am I doing here? Dividing. by 2. So what are my labels now? 45, 90, 135, and 180. So your period is 180 degrees. Any issue with that? One more. Probably the easiest one of all. It's a tangent. And tangents, you know, are asymptote squiggle. What's the amplitude? None. Don't have one ever for a tangent. These are supposed to be what? 90s. But whoa, I have divided by a half. So 90 divided by a half is 90 times 2. So my real labels are negative 180 and 180.
Yes.
Which means my period is 360. So anybody that wants to practice some more of that during class, come on in. Anybody that wants to take the quiz before the weekend, get it over with, can do that right after school. Otherwise, that's what we'll do first. Actually, I don't see, oh my gosh, it'll be Tuesday. Oh, Lord, children. You might want to think about coming in